Burns, where are your shoes?
Okay, today is the 30th? Wow.
Yeah.
Wow.
October 1st.
Oh, man. Time goes by so.
Q4.
Yeah, Q4, yeah. Oh, boy, does time fly by. Jeez. All right, 0, -2. Okay, that's here. -5, it'd be down here somewhere. 0, -2, -5. 6, 1, 7, up here somewhere. 4, 0, 3. 4, 0, 3, here somewhere. Okay. Well, it's possible they're collinear, okay? Doesn't quite look it, but it's certainly possible that they are. So what we're going to do is find vector PQ. I'll do PQ first. 6, 1 minus -2, 3. 7 minus -5, 12. Let's find vector QR. Vector QR is going to be -2. -1, -4. Question is 1 a scalar multiple of the other?
Yes.
If it is, yes. If you take this multiplied by -3, you'll get this one here. So they are parallel to each other, hence they are collinear. Okay? And if you were to do the third vector, PR, you would find that those also would be a scalar multiple of these two. So let's just verify this. You get 4, 2, 8, and yes, indeed, this is a scalar multiple of the other two, which clinches the case. We already knew that they were. Okay, that's what you have to do.
So if they're a scalar multiple of the other, you can find one common scalar between the two.
Yes.
You'll know if they're parallel and collinear.
Yes. And since they share a point, if you do PQ and QR, they share the point Q. So it's not like you can have these 2 points here and 2 other points here. They share a point. And the only way you can have these be scalar multiples is if they're collinear.
Okay.
Okay?
All right.
And it's not tilted. Okay? Because of that shared point. Yeah. Okay, any other questions on homework?
Yeah.
Anything? Yeah, go ahead.
All right, now we're doing one. Determine whether U and B are orthogonal, parallel, and neither.
Okay, go ahead.
So U is 2 and 21.
So this is a vector, I take it.
Yeah, this is the next homework.
All right, 221, yeah.
And then B is 3/2, -1/7.
-1/7?
Yeah.
Wow. Pretty weird. Okay. So what we're going to do is find the cosine of the angle between them. If we find the cosine of the angle between these two vectors, that'll tell us everything we need. It'll tell us whether they're parallel to each other, tell us whether they're perpendicular, or neither. And those are your 3 choices, right?
Yep.
Okay, let's do it. Find the cosine of the angle by taking their dot product over the product of their magnitudes. That'll give us the cosine of the angle. Dot product is 3. Oh, this is not too bad. 2 times that. That's 3 plus -3. Wow, that's 0. That's good. So the cosine of the angle is equal to 0. If the cosine of the angle is equal to 0, the angle must be pi over 2, 90 degrees. They are orthogonal or perpendicular to each other. There you be. Okay. Any others? Okay. Dan, let's see if we can get this rolling here. Dan did a parallel pipe head thing where you can change the coordinates. It's cool. It's just plain cool. That's all it is. So if you can go, if we can get HDMI connected to it, and usually
I got direct HDMI.
yeah, you got direct. Okay, so here you go. Let me get this out of the way.
So do you want to do the presentation or do you want me to speak to?
Hey, Dan, that's up to you. I would prefer that you do it, but it's your call.
Go ahead.
All right.
Just for the
Okay.
code.
Here's what we have. We have nothing yet. we have HDMI. I'm not sure what that 9XXXX is up there.
Shirt size, isn't it?
A triple X. Triple X website. I wonder what that's all about. Now, hold on. The thing was on off here, but the document camera was still working. I just turned this thing on with the HDMI. So this, okay, now give it a second or two. This should work. This should come on. Z assured me that it's all working.
Yeah, but are you doing it right?
What?
No.
C assured me it was all working. That may be a problem. It could be that you have to have the monitor on. Like my MacBook, it has to be on 720p. It's possible that you have to do a Windows P thing and do a sharing.
Yeah, it's seeing it and it's saying that it's duplicating the display. Let's see, where do I change aspect ratio? Darn it, this new Windows.
This is Windows 10?
Yeah.
Yeah. Does anybody know how we changed the aspect, the resolution, display resolution on Windows 10?
Right-click the desktop and
Yeah,
try preferences.
just in preferences, dude.
All right, right-click the
Come on,
desktop.
Dan, you can do this crap.
This is what I did.
Display settings, yeah, that sounds right.
That's what we're
And that's where we're at.
Doing math.
Yeah, that's what we were already at. It doesn't have screen resolution anywhere in here.
Did you just email him the
Computer people.
file?
Assemble.
This is in Mathematica. He's going to, the demonstration's in Mathematica, but we're just trying to get the thing up to here.
Why don't you
It's
just
possible
send it to you, Burns?
you could send it to me and I could do it if my Mac does work.
Try switching it back to the doc cam and then back to HDMI again.
Yeah, that's true. I'll go to DocCam and we'll switch it
I
back.
was screwing up the colors before too. Like
Yeah.
when
Sometimes things like that, okay, there's the document camera, that's working, and now I'll go to HDMI.
try it out.
Yeah, you know what? Things like that do work, though. I mean, here, let's see. Oh, we got the triple X again. Ooh. I'm not
Yeah,
sure.
just stick his computer under the document camera.
We could. Uh-oh.
Incompatible videos.
Almost always that means a resolution problem. Okay? Incompatible video thing. Almost always, that's what it
Unplugging and
means.
The
replugging.
more you know.
I'm just saying, like just today only.
Not reacting.
What is it? Half by slide.
No. I think, Dan, maybe what we should try is
Particular reason.
send me an email. Well, let me see if my laptop works. If my laptop works, then if you send me an email, we'll do it that way.
Yeah.
All right. Okay.
Oh wait.
I don't
Got the
know.
little backstory. But come on, man.
It says we're making
It's kind of funny because
Oh my God.
grab.
I went around to every room, right, and to do the technology to see what rooms were working, which ones were not, and things like that. It was always the case that the Dell computer worked instantly with no problem. Just plug it in, bam, work. And it was always the Macs that were problem here. But it's just surprising, man. But maybe it's a function of Windows 10. I don't know.
Mine's a Toshiba, not a Dell.
Oh, well, it's still a Windows thing, though. Here, let me see. If mine works, then if you email it to me, we'll do it from here.
I might go actually. I might go out.
Oh, really? I have like a.
There it is. The colors are weird, which I've been told was a connection or cable problem. But at least it does work. So if you send me that, and I'm going to get my Ethernet connection here. So I should be able to get my.
We need to clean this thing up.
For all those files.
Oh, yeah, that's true. You're
Yeah,
right.
It's like
You're right.
Click on one.
It is a mess, and I do periodically clean it up, but
It's time for intervention.
intervention.
Annually.
Eric, tell him what you
Yeah. But it's,
The outfield.
what's that? Oh, that was in my backyard.
That is
Oh,
beautiful.
that is so cool. That's a juvenile. That was the baby. That was last year though. We didn't have any babies this year.
Oh, that's,
I know. All right, but
Maybe next Friday.
yeah.
what's that?
Maybe next Friday. Just kidding, it's the fall, it doesn't work.
Did you send me that? Okay.
You'll find a raining blueback or something. I don't know birds.
Cool thing. Kangy sounds more like a Pokemon. Hey, I don't know what you can find out there. Yeah.
Especially with the new Pokemon Go app that's coming out. There's so much stuff.
Okay.
Yeah, it's gonna be coming out. It's gonna be, yeah.
All right, here we go. Let me, yeah, let me get this so I can at least get a handle on this.
You have to enable dynamics.
All right, let me do this.
Put field dynamic.
Oh, wow. This is so cool. It's not funny. All right, I'm at the, okay, so this is the top, right? Dan, I'm at the top? Okay. So let's do that. And we're going to run this. And what we have, now where do I put in the, oh, here they are. I see them. Okay. So here's the basic one. It's a little tight, but let's see if we can open this up some. You have some good numbers here, Dan, that you've done? No. Okay, so all right. Let's change this to, let's say, -2. If I swing that back over that way, let's see what happens there. This is much better.
Oh my God.
Just click out of the box. Don't hit enter.
Okay, just click out of. So it's done, right?
Yeah.
You did it.
Yeah.
This is so cool.
Interesting color choices there.
Yeah, they're neat.
Very good use of primary colors.
And this
Oh, yeah.
still-
Okay, so what you have here, and I'm going to increase this somehow this way. Okay, so here's A, B, C. Here's the cross, A cross C. This is perpendicular to the plane determined by A and C. Although it's difficult to really see that, but this is so cool looking. Oh, look at that! Look at that! Oh man, what's that? That is so cool. Wow. Okay, and we can change these. If I change the B one, if I go negative with the B,
In the box.
what's that?
In the box, Burns. Come on.
Oh, I'm sorry. I'm sorry. You're right.
Just click out of it this time.
All right. All right. Do -2, and all I gotta do is click over here, say.
Yeah.
Oh, wow. That's cool.
Shit's just getting crazy.
Oh, this is cool. Now, this vector here, there's B, A, and C. What is this vector here telling me?
That is the height with
That is the height. Okay.
with respect to B. It's the projection of B on A cross C.
I got you. Wow. So if you do B on A cross C, you drop a perpendicular here, you're going to get this vector, and that's what this purple vector is here. It's that projection.
Tries to get that better in the perspective, but it really doesn't get any better
Yeah,
than that.
yeah, that's cool. Ah, that's great. That is so cool. All right. Well, you got more stuff down here?
Yeah, there's more stuff. Wow.
Okay. Okay, and if I do this,
I think we should have Dan write the final lab.
yeah, I'd say so. I think if he does, you guys are in some heap of trouble.
Yeah,
though.
Dan, you gotta keep it with the copy paste theme.
Yeah. All right, what do we got here?
Just click and drag.
Oh, wow.
What?
Oh, that is nice. So what it's doing is calculating the sum and difference of those two vectors, correct? And plotting them as you move them. Oh, jeez, that's so cool. That is neat.
Burns is having a math game.
Wow. That's cool. That's good stuff. Thanks, Dan. All right.
Thanks, man.
Okay, let's let me quit out of that. And back to here. You got that? All right, good deal. Nice. Good stuff. Thank you. All right, let's go back to the document camera here. Okay, we're going to talk about some surfaces in space. We already have some surfaces in space. We have spheres, okay, which is also known as a quadric surface. Any surface having this form. These are quadric surfaces. Ax squared plus by squared plus cz squared plus, and then you've got possibilities for dx, e, y, f, z plus g equals 0. Those are all quadric surfaces. The sphere is an example of a quadric surface. It's a quadric surface where A equals B equals C. Okay, you complete the square, get the center and radius. But we have obviously all kinds of possibilities for quadric surfaces. And to determine what they are, here's what you're going to be asked. Here's what I want you to be able to do. I want you to be able to tell me what are called traces, okay, of these quadric surfaces. You find traces of a quadric surface by letting, here, let's do one. Let's do a simple one. Let's take x squared plus y squared plus z squared equals 1. That is a sphere. How do you find its quadric surfaces? First of all, in the xy plane, you let z equal 0. And what you're finding here, this trace that you're finding, is the intersection of our, yes?
Sorry, one thing.
Go ahead.
Is that a G?
That's a Z. My pen,
Just above it. At the end, it says
G.
G. Okay.
That's a G right there.
What does that represent?
Yeah,
That's a constant.
Can we just use K for
So
now?
those are just examples of
It's a
constants.
G count. So.
A, B, C, D, E, F, G are all constants.
Okay, so I said the constant D, not a dx.
What's that?
That's not a dx.
Wait, one at a time. What
So
the?
that's not like a derivative, like a dx.
No, I'm saying if you have, see this thing right here? This is a quadric surface where A is 1, B is 1, C is 1, G would be -1, okay, equal to 0. This is an example of a quadric surface. Anything that has this form, the A, B, C, D, E, F, G, are all constants. Is everybody okay? I obviously didn't do that very well, okay? This is an example of a quadric surface. This is a unit sphere whose center is 0, 0. And what I'm asking you to do is find what are called traces. Okay, you find the traces of a quadric surface by finding the intersection of the surface with xy plane. Okay, that would be this guy down here. ZY plane, okay, XZ plane, but the three coordinate planes with those three planes. And how do you do that? Well, you find the trace that this surface makes with the XY plane by letting Z equal 0, okay? Z equals 0 is what? It's the XY plane. So what are you doing here? You're finding the intersection of this surface with the XY plane. That's its XY trace. It's that intersection of the surface with the xy plane. If you let z equal 0, what do you get? You get x squared plus y squared equals 1. That trace in the xy plane is a unit circle. Okay? It's a unit circle. X squared plus y squared. If you do the xz plane, You do that by letting y equal 0. And if y is 0, you get x squared plus z squared equals 1. And what is that? That is a unit circle in the xz plane. Okay, what's the xz plane? This is the x-axis, z-axis. This is the xz plane. The trace is a unit circle. This is a quarter of it here. It goes down below and then over to the other side. So here's our sphere. Our sphere is centered at the origin 0, 0, 0. Okay? It's got a radius 1. Say 1 is here. What we're looking at here is 1 octant of that sphere. Okay? 1 octant of that sphere. We just saw that the xy trace, the intersection of our surface with the xy plane, is x squared plus y squared equals 1. That's a unit circle in the xy plane. This is a quarter of it. Continues on that side, continues over there. Everybody with me on that? Okay. The xz trace, the intersection with the xz plane, is x squared plus z squared equals 1. That's this unit circle. That's a quarter of it here. Okay? Okay? Can you imagine that sphere right here and that trace like that? Like that? You can do that. And then yz trace is the intersection with the yz plane. You do that by letting x equal 0. If x is 0, you get y squared plus z squared is equal to 1. And you get yet another unit circle. So if you were to draw these, here's our sphere. Okay. What I've just drawn here is the xy trace. It's that unit circle in the xy plane. Okay. The xz trace is again a unit circle, okay, in the xz plane, and the yz is another unit circle. You've got unit circles. You got 3 of them. You got cut that sphere with this plane, you got a unit circle. Cut it with that plane, you got a unit circle. In this wall, out the other side. Cut it with that plane, you get another unit circle. The traces for that sphere are 3 unit circles, okay? 1 in each of the coordinate planes, all right? This, that, and this. Slice it up. Okay, that's the easiest one, all right? What else you got, though? You got all kinds of possibilities here. What about something like this? Suppose you have this quadric surface, x squared minus y squared plus z squared, let's say equals 1. That's a quadric surface. What do you get for traces here? Well, let's see. Let's do the xy trace by finding the intersection of this with the xy plane. You let z equal 0. Okay. The xy trace is the intersection of the surface with the xy plane. That's called the xy trace. Let z equal 0, we get x squared minus y squared equals 1. And what do you get there? What is that thing? Hyperbola. That's a hyperbola. Okay. What about the xz trace? That y equals 0. What do we get there? We get a circle. And let's take the yz trace. We'll let x equal 0, and we'll get, what do we get here? Hyperbola again. Okay? You get 2 hyperbolas, okay, and a circle. Okay? And I can picture this thing. Okay. Hyperbolas, this way and this way, left, right, front, back. Got to be coordinated here, which I'm not. This way. And then when you slice it this way, you get the circle. Okay? Can you see that?
Yes. Kind of.
I know. Actually.
Yeah, I mean, I like your little hand motions and everything.
Dude, keep that Mathematica.
Yeah.
See, the problem with the Mathematica, though, it's a problem because these things are not functions. So you got to do square roots and plus and minus square roots to get top half and bottom half kind of thing, or else you do it parametrically. And the parametric forms are not easy. Even the sphere, parametrically, is not an easy thing. It's like x equals r sine cosine, and y is equal to cosine squared minus sine squared. You get these things parametric, but they're a little bit complicated.
Well, that's why we have Dan here.
One of them is
Yeah, that's true. But anyhow, this is, I'm only, for the traces, you don't even have to picture it though. For the traces, we could do this without knowing what the thing looks like. It would be nice if you could picture it.
But it doesn't really matter.
What's that?
It looks like an apple with white taken out of it, like circular on top and then cuts in on the sides.
Well, what you did with your hands was perfect, but I don't think apple with a bite out of it.
An apple, 4 bites taken out of it, one on each side.
Like just the apple core.
Okay, got you. Just the apple core, 4 big bites, 2 bites, those 2, and you get the apple core. Yes, I agree with you.
Okay.
I agree. That's a good shot. That's good. All right, what other kind of surfaces do we have in space? We have surfaces, well, these have all 3 variables. What kind of surface do you get if you have only a single variable? What about this surface? What the heck is this? What is that?
Oh my God.
I know it. What is it? What is this? Anybody know what this is? In two space, we get a vertical line. In 3 space, it's going to be a plane. Very good. Very good. Are you into it? Or was that Ted?
No.
Oh, was it? Oh, it was Brian. All right, but anyhow, think about it this way. Start x equals 1. Here, let's go out to here. That's the origin. This is 1. Here's x equals 1 on the x-axis. Okay? There's no y coordinate here. There's no y variable in this definition. What does that mean? That means every y, it doesn't matter what y is. Okay? Y can be 1, 2, 3, 4, etc., or negative. That gives me a line in the xy plane, this vertical line, because y doesn't matter. There's no y. But there's no z either. What does that do? It says that take any point, it doesn't matter if z is 0 on the xy plane, or 1, or 2, or 3, or 4, or negative. Take that line and move it perpendicular to itself this way and that way to generate this plane right here. Okay? That's what that does. Start at x equals 1, move it this way and that way because there's no y, and move it straight up and down because there's no z. That generates a plane. That's a plane x equals 1. Okay? Y equals 2, plane. Y equals 2 there, plane this way. Z equals 5, exactly, right there. Okay? Right there. Z equals 5. All right? Plenty of your heads, maybe. Okay? Let's take one where we have one missing variable. Let's see if we had something like this. What would that be? What is it? Ellipse in the xy plane. Well, it is an ellipse in the xy plane, more specifically a unit circle in the xy plane. But there's more to it than that.
It's a column.
It's a what?
It's a column.
A column. Yes, it's a column. Yes. It's a cylinder, okay? Column works. Take the xy plane. X squared plus y squared equals 1 is a unit circle. There's no z. What does that mean? You could take that unit circle in the xy plane and move it up parallel to the z-axis and down. Okay? That's what you get. Because there's no z coordinate there, it doesn't matter what z is. All surfaces that are missing a variable, whether it's x, y, or z, are called cylindrical surfaces. Okay? That one in particular is a cylinder. Okay? These are all called cylindrical surfaces. Okay? When they're missing a variable. What they have is a generating function. Let's take y equals z squared. So. That's a cylindrical surface. It's missing a variable. It's missing the x. So what do? You start with a generating curve, y equals z squared. Well, there's the z axis, there's the y axis, that's the yz plane. Start in there with y equals z squared. What do you get in that plane for y equals z squared? What's that? Yeah, but let's just start in that plane. What do we get in the plane first? A parabola. Okay? Y equals z squared. So when z is 2, y is 4. When z is 3, y is 9. You get a parabola. It comes down here and goes beneath the floor. So here's one branch, comes down this way. There's no x coordinate. So what happens to that thing? That thing moves this way. Okay? Down the x-axis this way and that way. Okay? This, we can, here, I can show you this one. This one we can do. Let's do this one. I've got the computer here. Let's do it. I'll show you this one. These are done with parametric plots. Okay? Parametric plot 3D. I can show you this one. Yeah, I can show you this one. Okay, so what did I do before? Shut it off and then on again, or do?
Did something.
Hit it.
What he's got right there in his hand is exactly what we got. Okay, it's that parabola, but you got to, but you got to turn it though. You got to turn it so it's going. It's this way. Yeah. And then tilt it 90 degrees this way. No, leave it just like that. Leave it just like that. That's perfect. Well, so, all right, shut it off and then on again, you think?
Oh, no.
Wow.
It's still connected. It's still the same way I had it before. Okay, I shut it off. I think you got to do... Okay, now turn it on again. That's what it was. My machine was asleep. That's what it was. There it is. Okay, it was my bad. The machine was asleep. Let me just show you this. Whoa, okay.
That's the way to do it.
Okay. Let's do a parametric plot 3D. And the equation was y equals z squared. So we'll let x equal t, we'll let y equal u, and z equal u squared. Okay. Okay. That way the z is equal to y squared. Is that what I had? No, I want y equals z squared. I'm sorry. So it's the other way around. Okay. It's the y that's equal to z squared. There's the y equals z squared. And the x is missing, so it gets its own variable. It's independent of those two. And we're going to have t go from, let's say, -4 to 4. And we'll have u go from, let's say, -2 to 2. Okay? And what we should get is this parabola moved just exactly what he had. Okay? This is right down that x-axis. There's the parabola that we mentioned right here. Right? Just like that. And move it right parallel to the x-axis. You can do an axis label and various things here. Let me put an axis label on this. Okay, and there's the x-axis here. You can, I don't know if you can see it even, but that's what it is. Now, if you want to take this and move it parallel to the z-axis, what you would do is let the z be its own variable, and let this be u. This would be y equals x squared. Okay, y equals x squared. A parabola in the xy plane moves up parallel to the z-axis. Okay, and that's exactly what you got. There's the basic parabola here moving parallel to the z-axis. Okay, so that's what you got. Those are all cylindrical surfaces. Okay, when you have a missing variable, what they always do is start with the generating curve in the plane of the two variables that are there and moving parallel to the axis of the missing variable. That's what cylindrical surfaces do. Okay. Yeah, that's about it. Okay, let's. I'll see you tomorrow. We'll do the last section. And yes, Adrian.
You gotta tell a story of how you see it from the light.
Oh, I do have time. All right, here we go. You guys haven't heard this before?
No. Oh, you told me you guys.
All right.
I
Here we
want to
go.
hear how you
Did you use math?
No, I did kill him.
end someone's life.
And I saved someone's life.
Okay.
Okay, here we go. What do you want?
Was he asking for it?
Yeah.
Yeah, kill him.
All right, here we go.
You gotta redeem yourself.
Yeah.
Kill
All right, here we
him.
go. I used to be president of the Springfield Chess Club. This is a long time ago, 1987. I was playing chess a lot. And we used to go to the Springfield Boys Club on Carew Street. Every Tuesday night, we'd meet there at 7 o'clock officially. But sometimes people would come early. And there was one guy, Curtis Tuttle, old guy, blind, practically. He wore a visor. He had his own chess set with the white and the black pieces had different markings. So when he would play, he would set up his pieces and he would constantly touch the pieces so he knew what they were. Because I think he was like officially blind, okay? But he was a fierce competitor. He was a good player too. He was really good. And he would come in early sometimes and he would set his pieces up and just sit at the table there and wait for someone to sit down and play, right? So never spoke, never said anything, ever. So I sat down there to play him, and we played this game, no clock or anything, and the game went on for a while. And it was a really good game, but I won. And when he resigned, he didn't say I resigned, he just messed his pieces up and then started putting them back again. When he put them back again, you knew he wanted to play again. So we played a second game. Okay? And so it was a really good game. It was a good game, but I wanted it. Now you can see that he was getting a little bit upset. So he messed the pieces up, and he put them back down. He just kind of smashed them down on the board and put them down on the board. Now here's game 3. Okay? Now he's leaning over the board. He's got his visor on, and right in the middle of the game. It was a good game. It was even. It was dead even. It was a good game though. Beads of sweat plopped onto the board. Just run right onto the board. Just right off his visor onto the board. And then what he did, he took his pieces, right in the middle of the game, put them in his little bag, okay? Right in the middle, he didn't say anything, and walked out. Right in the middle of game 3. Okay? Next step, Springfield Papers. Curtis Tuttle, age 76, found dead outside the Springfield Boys Club last night. He had a heart attack right in the middle of game 3. The beads of sweat were coming down. That's when he had the heart attack. He managed to walk out of the building, got to the sidewalk, collapsed, and died. That's how I killed Curtis Tuttle.
Are you serious?
I'm serious.
Wow.
That's what happened.
How did you feel?
Wait, you didn't like see the ambulance come or anything?
No. We had no idea. I don't know how we got. I don't know what happened after that, but we never saw it.
When you guys walked up,
That's a true story.
Killed a man, like indirectly, but you killed him.
If it weren't for me, Curtis may be still alive. Maybe.
You chessed the man to death.
Right. I'm going to tell you when I say it too. Then here's when I say it. All right. Here we go. In the 70s, there was one great chess player in Western Massachusetts, David Leeds. He was a chess master, or the only master we had in Western Mass. All right. He was like the best by far, and he wouldn't even play in the tournaments because he was really just too good. He would play tournaments in New York or Boston, something like that. But he would go to Springfield Chess Club all the time, and we'd play 5 minutes, and he'd play. He was a great guy, okay? So anyhow, we were having this tournament, East Hampton. I can never remember the name of the academy. Williston Academy, thank you. There was a big tournament, it's called the Western Mass Championship at Williston Academy once a year. So we all played, except David Lee didn't play, because, you know, what the heck, it was way beneath him. So there's okay, hold on, I'm going to remember his name now. Stan Targonsky was one of them. He was a young kid, 14 or 15, but he was up and coming. You know, he was a good player, solid. Got a big tough man in Chicopee for a while. It's probably retired. It was so long ago. But anyhow, Stan Targonski was in this tournament. I was in the tournament. Irving Pierce was the other guy in the tournament. The guy in the 50s, big burly guy, you know. Kind of a mean guy. Nobody liked him. I couldn't stand him. Because he hated to lose. He was a bad loser. I didn't. Okay? So anyhow, the tournament comes down to the last game between Stan and Irving Pierce. The winner of that game, or the winner of the game wins the tournament, or if Irving Pierce managed to draw, he would win the tournament because of the way the tiebreaks work. So Irv had to either win or draw to get the trophy and be Western Mass champion. If Stan managed to win, Stan would be the winner, like 15 years old, and it was really cool. It was really good. As a matter of fact, Stan and I played it in the tournament the round before. Stan beat me, and that game ended up in Chess Life magazine, the magazine that you get as a Chess Life a USCF member. He sent it in because it was such a cool game. But anyhow, so here's Stan and Irving Pierce playing this game. And it's going on, and all the other games are done. Everybody's standing around the table watching these two play. Okay. Well, in a tournament like this, the tournament director has the option of adjudicating the game if it's taken too long. Because other people have to go, and he has to give out the trophies and do that kind of stuff. So he has to adjudicate the game. Now, the tournament director is really afraid of Irving Pierce, because everybody was. He was just this big bully guy, and he was afraid of Irv. So the game is going on. Stan's winning, but not by much. He can't figure out how to do the win. He just can't figure out. There's a kind of a maneuver that he had to do, and he couldn't see it. He was winning the game, but he couldn't see how to really put Irv away. So after a while, Irv says, forget it. Okay, come on over here, tournament director guy, whatever your name is. You adjudicate this game. He's not winning this game. This game is a draw. And I'm going to win this tournament. So the guy looked at it, and he said, you know what, Irv? Yeah, you're right. You're right. This game is going to be a draw. Stan's got an advantage, but he's not being able to do it, to finish it off. At that moment, Dave Lees walks in. Okay? He walks in. Stan shows up and says, Dave, come here, look at this game. I can win this game, but I can't. And Dave says, yeah, Stan, just do this. and of course, Dave was right. You know, all Stan had to do was do that, and he would have won the game. Now, what's the tournament director going to do? He has to say, yeah, you're right, Stan, you're going to win this game. I have to adjudicate it in Stan's favor.
He wouldn't have been able to do it, though.
What's that? Well, I know, they're a little iffy here, this whole thing. But Irv goes bananas. He just goes wacko. He hates Dave anyways, because Dave is the best player in Western Mass by far. Irv kind of thinks, you know, if Dave were out of the picture, Irv would be the best. What does he do? He starts choking Dave. I'm serious. Did you see the video of Papelbon and the dugout? He was choking the guy the other day? That was Irv Pierce. He starts choking him. I swear, and you could see Dave is turning blue. So I jumped on Irv Pierce's back. And I wrestled him down onto the chess table. The chess pieces were flying. And onto the seats, the pieces went flying, the chairs went flying, and finally he let go of Dave. Dave gets up, he's choking, he's gasping for breath. And I saved Dave. Okay? That's what happened. You know what's ironic? Just one last word about this. What's ironic? Afterward, Dave and Irv became friends. Irv Pierce hated me all the rest for years after that, where Dave and Irv got to be friends, but Irv always hated me. What? Don't
Did you get the notes from last week?
I've got everything yesterday. This is it for today.
So, which one's the first one?
That's first. I didn't do a heck of a lot, did I? But I have everything else. Am I still recording?
No, good. Actually, I don't know. I can't tell. You gotta change.
change it to.
What do you mean? And like, wait.
Oh, document.
No, like just turn over and she's
It is a document.
He just said that.
Oh, he just did it.
My question is how
Oh, it's so bad though.
It's recording.
It is recording. Oh, geez, it recorded my whole story.
Yeah, that's great.